Hi, this video we're going to look at another example of 2D resultant force, but this is from Webwork 1 problem 1, and this again has its own uniqueness. Okay, so it said passenger jet is shown below, and the wind provide lift force. So F lift right here, perpendicular to the airplane. Okay, so it's slanted. It's not like up and down. Then the engine provided the thrust, so F thrust is 10 kilonewton, and also there's drag caused by air resistance, F drag. So F drag and the thrust at the same line. However, it's not a horizontal because the airplane is in a slanted position. Then the plane weighs 24 kilonewton. The weight is just going to be applied at center of gravity straight downward. So that's only force that's going straight up and down, that direction. And the jet is pitched at a 7 degree from horizontal. Then ask to find the magnitude and direction of this resultant force. So first, when you look at this problem, you see there are multiple forces. You have along the axis of the airplane, which we call x prime, right? Normally y it's perfect horizontal and vertical, but don't be limited to that because you can draw your coordinate anywhere you want. So for this example, they said this is gonna be my x prime, and as now I'm drawing one that's perpendicular to it, that's gonna be my y prime. Why not? So get back to this one. So there are multiple forces down there. There's drag and the thrust. It's along the x prime direction. Then you have F lift. It's going to be at y prime direction. Then you have weight that's just going downward. Well, now let's think about it. We have to determine which coordinate we use. Majority of problem we use xy coordinate, being perfect horizontal and being perfect vertical. However, if we were to use xy coordinate, what happens? You will realize the weight is on the y coordinates, on like going downward on y. However, the drag and the thrust, all of them. Okay, so in that situation, the F drag and F thrust is going to have to be decomposed at x direction, and also F lift is going to be decomposed to x and y direction. Well, you have to decompose three forces. Or would you rather to go with x prime, y prime coordinate? Like I said, why not? In that situation, you will be looking at thrust and drag along x prime direction. They are perfect line on x prime, so there's nothing needs to be decomposed, right? You're just gonna have fx prime direction. And the same thing for the lift. The lift is on y prime. You don't need to decompose. So the only force that needs to decompose is F weight, to decompose F weight to x prime and y prime. Well, so I would love to, personally, I will choose x prime, y prime. That's gonna make my life way easier when I solve this problem. So that's where we're going. So now let's go ahead to solve this problem. I will just maybe do some like skeleton work here, and I will let you to finish the calculation. So what we do is we're going to look at those four forces, and we can create our table. And the first force will be, let's call it F drag. The second one will have F thrust. Then we'll have F lift. The last one will be the weight. So those are the four forces we need to find its resultant. And here, instead of x direction, I'm going to decompose to x prime direction and y prime direction. Now we're just going to try to fill those cells. So F drag is right here. So it's going we're using x, y prime, x prime, y prime coordinate. This is f drag. It's on x prime direction and it's pointing to the positive direction, right? It's pointing to the, right. So in that case, if my f drag is given, it's 11 kilonewtons. So that's all of them. All of the 11 kilonewtons on x prime. The y prime is going to be 0 because it's on x prime direction. Nothing needs to be decomposed to a y. It's set on x prime. Now let's look at f thrust. F thrust is going that direction and it's on negative x prime direction, and it is telling us 10 kilonewtons. So what should I write here then? Negative 10, right? Because it's on negative x prime and there's no y component on thrust. Now let's look at f lift. F lift, it's on y prime direction, so it's going that upward. So since all of them is on y prime, there'll be nothing to be fractioned to x prime direction, so that's 0. And y prime, the lift, is that it's 24.5, so that's going to be positive because it's going upward. Then only thing left is weight. Now let's look at the weight. Weight, I'm going to use red color here. So this is my weight. Weight is always going to be going downward, straight downward, and that's our weight. And the weight, now we are working on x prime and y prime, so we have to decompose that to x prime and y prime using the rectangular component. So you are using rectangular component too. Now it's just your coordinate. Now it's tilted. It's like oriented, tilted. That's all. So same principle though. And so what do we know? We know this angle is theta. So this is x prime, and that's where airplane is. And the perfect horizontal is here. So that's our theta. And my theta is 7 degrees. So how do we use that angle to help us find the rest? Now let's think about this. Is perfect horizontal line. That's basically your x direction. And this is weight. Weight is going to be at perfect downward. And that makes us a 90 degree here, right? So if that's 90 degree and this is 7, then we know this angle right here, this angle right here, that will give us 93 degree. That will be helpful because that angle is going to be right there, right? Same angle here, 93 degree. So then we can decompose that weight. So if I would isolate that weight out so you can see better, that's our weight straight downward, and this is x prime direction. This is the weight x prime direction, and this is the weight at y prime direction. We also just figure out this angle being 93 degree, and this is our weight. So this weight at x prime, regard to 93 degree, x prime is adjacent, so that's going to be cosine. So that's going to be weight while we are solving. That's given 24 times cosine 93. And y will be positive here because it's going line on the positive direction of x prime. Then we're going to look at fy prime here. And this angle is 93, so it's opposite. So it's going to be sine, 24 times sine 93. However, think about the sine. This is going that direction. That's basically opposite of a negative y prime direction, so that's going to be negative. So watch out for the sine. Then you know all of this now. The rest is going to be easy, right? You just going to figure out the summation. So summation of all the x prime direction. And we're going to do the same thing, summation, add all those together, summation at a y prime direction. Then we can find our resultant. Resultant will be summation of x prime square, summation of y1 square, y prime square. That's going to give us the magnitude. in order to find the angle theta, right? Theta will be the same thing, will be inverse tangent of Fy over Fy prime over Fx prime. And now let's go back to see what they're asking us about the direction. It said counterclockwise with respect to the positive x prime axis. So they're going using x prime anyway, right? So we're on the right track. But just if your angle theta is not correct, you have to think about this angle you calculated likely is going to be maybe clockwise from x prime. So you might need to do some alteration, either like a 180 or 360 minus, but that's something you needed to use the judgment at the end to figure it out, okay, for this angle here. All right, that's all I have. And again, this is a unique problem because introduce the unconventional coordinate. Again, we don't need it to be limited to perfect horizontal vertical. When problem comes like this, be flexible, be smart about it. It's all about working smarter, right? And not what do you say? Work smarter but not harder, you know? So this is example for that. All right, I'll see you next time. Bye.